Good. Thank you. Good afternoon, everybody, and welcome to today's Alarm webinar. We are delighted to have you with us for this session dedicated to multi-criteria fire sensors. These sensors have been available on the market for a number of years now, and they represent a major step forward in fire detection technology. By combining the different detection principles, they enable earlier and more reliable identification of fires, while at the same time significantly can reduce the number of false and unnecessary alarms. This not only enhances fire safety, but also reduces unnecessary disruptions. Today, we have 4 experts from our Alarm members who will guide us through the different aspects of this technology. Eike Friedrichs, specialist in fire standardization and certification at Bosch, will explain how multi-criteria fire sensors work. Thomas Litterust, specialist of standards and directives within the business development at Hackathon, and also chair of the CEN working group on smoke alarms and air duct detectors, will explain what to consider when planning and installing multi-criteria sensors. After that, Miguel Cole, fire safety expert at Siemens, an expert on fire technologies and digital fire, explains how European standards play a role in ensuring quality and consistency. Last but not least, Oliver Doerle will, an industry specialist at the detector testers, in testing and maintenance on fire detectors, will provide practical expertise on how these systems can be maintained and tested in an efficient and effective and compliant way. Why should you use multi-criteria fire detectors? It's quite simply because they provide a smarter and more resilient layer of protection. They adapt better to complex environments, ensure that warnings are raised when they should be, and help prevent alarm fatigue in both building occupants and responders. In the end, this technology is not only about smart sensors. It's also about safeguarding lives, protecting goods, and supporting fire services by reducing the number of unnecessary callouts. With multi-criteria fire sensors, we can improve fire safety for people and property, while at the same time reducing the workload of emergency responders.
It'd be nice to ask new people.
We invite you to ask questions at the end of the presentation, and please stay muted. You can also put your questions in the chat. With that, I would like to hand over to Anja Schevers, who will tell us something about Alarm before we start talking about multi-criteria sensors. Anja, please go ahead.
Hello, good afternoon, everyone. My name is Anja Schevers, and I would like to take you through a couple of things about Alarm. So basically, Alarm is the leading European industry association, and we present the fire safety and the security industry. So we are here for you to offer advice, to offer expertise within the industry, but also about the market. And we work very closely with the policymakers and with the standardization bodies. So our Alarm organization is split into 4 different sections. So it's the fire extinguishing section, the fire detection section, the service section, and the security section. So as you can see, we present all the important assets of this industry. We have more than 700,000 employees within this industry, and we present a 67 billion market. Right, and what are the things that we are working on? So if you look at how we shape the industry, we are a leader in innovation. So that means we are supporting innovations within that industry, which are also looking at the sustainability of different things. We are also supporting the single European market, which is really important for all the European companies to take advantage of a global market, because we are working with all the regulation bodies and with the European standardization bodies to ensure that we have high standards met. We are also looking at digitalization. We are at the forefront of looking at what the trends are in regards to that and making sure that we share the knowledge within the industry. Another important thing we are looking at is the training and making sure that we have qualified personnel within the industry. So to help really to design, but also then to install and maintain all of the different systems. And with that, we are also really working hard to make sure that we have a diverse workforce. So we are making sure that we have young talent that is also being able to be part of that industry and also being able to have a great diversity within the industry. And to finish that, we also are contributing to a green Europe because that will be an opportunity for growth. And now I would like to hand over to Eike Friedrichs, and he will dive into the big advantages of multi-criteria sensors.
Okay, so hello everyone, welcome to the webinar. So yeah, how multi-sensor fire detectors can help to reduce false alarms is what we'd like to tell you about. And I think that maybe to get you a sense of a notion, what basically the key of this is, it makes sense to, well, move away from technology for a second and understand how, well, you or in principle human beings would recognize a fire, right? So it's basically the sensors you have telling you that something's wrong. So you feel heat, yeah, there may be a cracking sound, you smell something, and you may see smoke and eventually a flame. And I think it's a combination in particular of the different sensations that make you then actually sure that this is a fire, right? So heat alone doesn't necessarily tell you anything. Yeah, smell alone, well, might be misleading, but it's the different sensations together that make you realize, well, this is a fire. Yeah? And that's a little bit how multi-sensor detectors work. So if we translate that into technology, what I said before, it's you can look at, so to say, different sensors that are there. So typically there are, well, three technologies that are deployed for sensing fire. This is one is optical. Yeah, so you might just detect basically principles. So you have a light beam where there's light scattered when there's smoke around. So this is actually kind of an optical way to detect. Then you just can simply detect the temperature, right? So this is what we call a thermal sensor. Or you could, for example, detect a certain type of gas like carbon monoxide, most prominently, which is an electrochemical way of detecting a fire. So yeah, so that's kind of the basic principles. Yeah, so the different ways how you would actually use sensors, and typically you have standalone sensor either do one of these three things. But if you look at those, well, what you need to realize is that the different type of sensors also cater different type of fires better, because well, if you want some fire types are hotter than others, so this is more like a thermal sensor that would be kind of good in the first place, yeah, while others produce more smoke. So this is why detectors in general are qualified against a number of test fires, and not only one, but still also the individual technologies are individually more or less appropriate for the particular type of fire to detect, right? So if you only use one type of sensor, you have the challenge to select the right one for the environment you have. And environment in that sense means what is the typical fire you would have to expect where actually you're gonna put the detector. Well, it might be, so to say, a warehouse full of paper. That would kind of provide a little bit like a different phenomenon first than a warehouse full of plastics. So, and what you also do not want is false alarms. And maybe to understand a little, I have this kind of graph here or graphics here where you see, yeah, basically kind of the different, well, so to say, events you can have. Yeah, like one that is, well, what you typically have, I have no fire, and also there's no fire detection. So that's kind of good from the perspective, well, from the fire, it's working correctly, nothing happens. Yeah, and then you basically have a situation where you have a fire and it's detected correctly. So not a nice situation, but kind of from the perspective of the fire alarm systems, this is what it should do. It detects a fire. What you absolutely do not want is a situation where you have basically a fire, but you miss the alarm. And miss basically means it's kind of too late, because at some point, I think it's typically always recognized, but it may be too late. And this is what you don't want. So if you just have, so to say, the wrong type of sensor or the wrong sensitivity available, right, then you're basically prone to miss an alarm. You do not want this. So what you can do is actually you tune the sensitivity of your detector in a way that, for example, it already gives an alarm at a lower temperature if it's a thermal sensor, or it gives an alarm when there's a lower optical value, it's how it's called here, when there are less particles in the air, so the scattering is less, or you already kind of let it ring an alarm when the carbon monoxide level is lower. But of course, this easily also gives you in a situation where you then cannot fall into a range where you get then you kind of have reduced the missed alarms, right? But you may have produced more false alarms because, for example, something like disco fog, yeah, will always be or typically be recognized by an optical sensor because yeah, it's getting foggy, yeah, so it's like there are particles in the air, but it's absolutely no fire. This is something where you basically have to optimize things, yeah. So no missed alarm, so that's a no-go, but also reducing the false alarm, because this is in principle, so to say, no harm done, yeah, because there's an alarm, but there's no fire. But of course, this is a nuance. This basically makes people weary when there's an alarm. The fire brigade will come, all that kind of stuff. It's costs. It's a very something actually we do not want to have. This is also, yeah, the key item of this talk. But those who have a strong technical understanding, yeah, I want to spend like a very short time here on this phase diagram. So if this is kind of confusing in the first place, don't worry, I'll jump over it, and it's not necessary to understand for the rest of the presentation. But if you like, this basically gives a depiction of how relatively, so to say, the different types of fires have relatively different ratios of carbon monoxide or well, like particle density or temperature. So for example, what you see here is disco fog, which is of course a non-fire event. You see very high value of like particle concentration, but it's cold actually, right? And it's also not related to carbon monoxide. While, for example, in a car garage, you definitely have some carbon monoxide in place, but it's also cold. While you have some fires, for example, this test fire 3, which is, I would say, if you look here, well, relatively having a relatively high CO value, but a low kind of, so to say, particle concentration in the air and a medium temperature range. So, right. So in this sense, you can kind of say these are real fire events that have kind of certain ratios of the different values. And you have to distinguish them actually from, which are given here in blue, the non-fire events, yeah, like a car garage, and which are kind of here you see with this phase plane separated. And that's kind of, so to say, the thing you do or you need to kind of engineer around to detect the fires and discriminate them against those non-fire events. Okay. And what you can do, well, of course, you can just go ahead and say, yeah, I make sure I just use all of my sensors. So I'll put on an optical sensor on in my room. I put on a thermal sensor and a carbon monoxide sensor. And well, you can also combine them in one housing, right? And then you have, well, what looks like it's one sensor, but it's actually 3, because it won't ring an alarm individually. So say again, the disco fog, yeah, that would kind of trigger the optical sensor. So that would give an alarm. Or the garage would kind of trigger the CO sensor, would also give an alarm. So in that case, you have, so to say, solved the issue of the missed alarms, because you absolutely make sure any of these phenomena is registered, but you have not kind of, so to say, ruled out the false alarm. And this is why you then actually can deploy kind of a little bit different setup. And that would mean you combine, yeah, the information you get. So for example, you do not just ring an alarm because the optical sensor is triggered or the thermal sensor is triggered. You just do some computation. Yeah, you just look at the different thresholds you have, and then kind of let with some algorithm the device decide. So when is now actually a fire alarm? And this is actually what multi-criteria sensors are about. They use the different. You can use, for example, optical and thermal, or optical and carbon monoxide, all of three of them together. But in this case, really what you do is you do not have them like individually bring in an alarm, but you crunch the numbers and kind of use the different information that is there to decide, okay, I do have basically an alarm from this side, high particle density, disco fog, yeah, but it's still cold, so I don't give an alarm because I know this would need to be different. It would also need to be hot, so that I would give an alarm. So that's what the multi-criteria sensors are about, the combination and the crunching of numbers and making use of the different type of sensors you have in a kind of combined mode. Okay. And I think that's so much about the technology. I think part of this will be repeated, maybe a little bit complicated, but will be repeated in the further slides as well. Okay, so yeah, so Thomas.
Yeah, thank you. So after we have heard from Eike about the different sensor combinations of multi-criteria sensors, I would like now to continue what we have to take care for while installing, configuring, and testing, and also the servicing of a multi-criteria detector. For an introduction, or before I start and get a little bit deeper into the details, I would like to show you one slide. Now I have to make sure that it works with, yes, now it works with the navigation, the ideal world of the detector environment. I think this is what we like to see, a properly installed detector at the ceiling. There is nothing around. It has its square meters to protect and detect. And so this is what we would like to see in practical as an ideal world. On the other hand, and there the planning and especially the maintaining of the multi-criteria sensor comes into effect. We have the real life situations of a detector environment. And I brought you also some example of these real situations, real life situation. Here you see a detector hidden behind a beamer, or that's something, if you are familiar with the business, I'm sure you also found that the cover, the lid is not removed. So of course it is not causing false alarm, but also not a real alarm in that case. Or there in this room, there might have been a party and somebody forgot to remove the lid. Or as you can see here, another real life situation where the detector is within the ceiling, so it is not free from obstacles. And the last example I have is where you have air ventilation, and this might also influence the detection of a fire or of the sensing element. And interesting enough, 3 of these 5 pictures are all pictures I've taken during business trips for UAlarm. So that is interesting what you see in different environments. Taking this into consideration, then we also have to know and to see here in this slide what different types of building we have to protect. So there is a very clean area. There can be museums or church buildings, and it goes on the other end until livestock buildings or recycling facilities. So you can imagine it is also important to know where the detector is installed, and that has also influence on what kind of sensing elements you program and you use for the fire detection. To conclude this part, there are different environmental conditions what you have to consider by choosing the right combinations of the multi-criteria or multi-sensor detectors. There are these general environmental conditions like dust, temperature exposure, humidity, maybe also radiation or EMC. And there might be signals or physical phenomena that could also influence the sensing element, like flickering, or there are different gases, fog, or even sparks. And what I showed with the ventilation, there might be air velocity. So this environmental condition, it is very important when you start to plan FDAS, a fire detection and alarm system with the detectors, to see what is the right detector and what combination of sensor can I adopt for having the most secure detection of the fire on the one hand side, on the other hand side, the least chance to have a false alarm. And this leads into the so-called approved fire protection system and also an update of the protection system. What do I mean with the fire protection system and its update? In the beginning, when a building is planned, part of the before the construction start is the fire protection concept that has a lot of different chapters, but in basically, or the most important parts are what kind of fire detection alarm system will be used in the building. What kind of monitoring do you have? Is it for the whole building or only for a part of the building? And then you also need a concept for the alarm. Will it be alarm that is for the total building or also only for it's kind of a silent alarm, or what combinations, what type of alarming scenarios you have? This has also to be in the approved fire protection system. And there will be also a part with control, requirements for control. For example, what happens with the elevator in case of a fire alarm, until a safety engineering control concept. Besides this fire protection concept, there can be other requirements to this fire alarm and alarming concept. It might be that insurance have special needs for protecting the building. There are also requirements from architecture side, what they expect in the building, how the detectors should be used and installed. And this also can have there can be additional requirements from the fire brigade or special use cases for the fire brigade. And this is a very important thing, and that's why in the headline it says, and its update. That means we have a fire alarm and alarming concept. And this is then also the basis for choosing the right system and choosing the right detectors and the right detectors and sensors combination for the building. And its updates means if the building usage changes during the time, it is important to update this concept, because we see this later. It can have an influence, of course, of the system itself, of the fire detection and alarm system. Now, if we go one step further towards the multi-sensor detector selection, I would call it, there are different aspects during the total life cycle of this detector. And this is a slide that was developed in the false alarm study from EURalarm, and I wanted to use it to show you which in each part of the life cycle of the multi-sensor detector you have to take care, and you can also make the right decision what kind of sensor to choose. This is then in the beginning, where you choose the product, that you have a look what are the optimized algorithm, or for the manufacturers it means to supply the optimized algorithm for the different combination of the different sensors within one product for the multi-criteria detector. Then in the planning, there are different aspects. I would like to point out one part, and that is then that you use or you choose the measuring principle for the detector depending on the place of the installation.
Maar Chris,
What we have seen,
hey, Lucas.
what there's a microphone not muted.
Nee, ik ben dus bij een webinar aan het volgen wat er wordt geschreven worden.
And it's a language I don't understand.
Waarom?
Yeah, the measuring principle in the planning for the detector, depending on the place of the installation. So that's important thing to for the choice for choosing the multi-criteria detector in the planning phase. Then there might be organizational parts during the life cycle that we say we can use the multi-criteria sensor by the optimize the alarm processes and how the information will be exchanged. For example, is it enough to have the alarm from one signal, or do we always need two different signals to get the alarm through, and things like that? These are more organizational parts. And then last but not least, during the maintenance, it is important when this detector is already installed to review the detector type and the settings, because there might be during lifetime of a building a change of the room or the usage of the room, or even the geometry of the rooms, because with these moving malls these days in modern buildings, it will change. So that is also important part during the maintenance of the detector. So you see the the aspects in the total life cycle of a multi-sensor detector. There are things we have to consider for optimized usage of the multi-criteria sensors. Eike already introduced different types of sensors in the EN54, and I would like to show you a different slide with the same contents. Just for recapitulation, we said we would take this slide as an additional explanation what the different EN54 parts of detectors will cooperate. So we have a set of standards that have smoke, as the main sensing element, and a combination then with smoke and heat, and smoke carbon monoxide, and also heat. So that is where the smoke is playing a role. And then in addition, we have the second sensing element, and the temperature. This can be used for enhanced measurement of the scattered light, of the optical part, but it also can be used as a single heat detector, or as you can see, in combination then with heat, carbon, and smoke detector. And then the third combination, which is the CO, the gases. Again, here there are different types and combinations where CO plays a role. For my knowledge, the carbon monoxide detector, which has not another sensing element, is not playing a high or important role in the usage of the detectors, but the combination, it can be a good way to acknowledge the sensing element, or to verify the sensing signal for the fire alarm. So this is again the type point detector with the different types in the EN54. Yeah, then before I hand over to Miguel, I would like to show you then with this knowledge of the previous slides, what is then the sort of the roadmap or the checklist for deploying multi-sensor detectors. And this is, by the way, this is the contents is written in a more in a better way, or not in a better way. It is written in a more detailed way in the URAlarm white paper. So you can also download this URAlarm white paper about multi-sensor detector usage, multi-criteria detector usage, and false alarm reduction. But here, as a summary, I would like to show you this on the roadmap. First, we have seen that it is important to understand the environment. What kind of building do you have? What are the factors? What are the different influences like temperature, humidity? And also, how is the building used? What kind of fire hazards are in there? And also monitor and future changes, and also have in the maintenance phase also have an eye on is the usage of the building, has it changed? Then the next aspect is then in terms of the selection of the detector itself. That means, what is the suitable sensor? Is it a smoke, a heat, or a combination of that? And it's not only the selection of the sensor, but it's also the sensitivity setting of the different sensors. What is the main phenomena you would like to detect, and can the other phenomena assist to a better detection and to reduce the false alarm? Another option might be that you look for a multi-criteria alarm verification. Then in the next step of the roadmap, then of course, it's always good to have a look on the compliance with the product standards. There are, as I pointed out, and Eike also pointed it out, there are EN 54 standards for these combinations. The part 29, 30, and 31, they are not harmonized yet, not yet harmonized, but still there you have a state-of-the-art of detection, so you can of course use this non-harmonized standard also. And then in the next step, it is also important to see how can the FDAS, the fire detection and alarm system, be integrated in the existing system. Is it compatible with other control panels? How will the communication protocol be used? And then for the system itself, you might know there's the EN 54 part 13 that you also make sure you have the compliance for the interaction of the system. Yeah, then the next step, then you install the detector, the multi-criteria detector. Then, as I showed you can use the fire concept and the alarming concept. You can also, there will be local installation codes. You will see in the next part of this talk what local installation codes exists. And of course, then you have to make sure the accessibility and maintenance and testing during maintenance. And then during the maintenance and testing, then it's important to have this routine to maintain it. You document also it, you do the troubleshooting. There is a good standard for this service provider who are doing the maintenance and the testing, is the EN 16763. And if it is necessary, if this comes out during the testing and maintenance phase, it's also important to replace the detector, to program it in the same way as it was installed, and for this recommended usage period. Yeah, so this is sort of the checklist, the roadmap. As I said, this is described in the white paper of the URAlarm about the same topic. And now I would like to hand over to Miguel to the next part.
Thank you, Thomas. Good day, everyone. So we have seen that there is a protection concept, there is an alarming concept, there is a control concept. After that, we will choose the sensors and we will choose the programming. And after that, we will have installed and commissioned a perfectly adapted system for the needs of that specific operation in each of the spaces that are protected. But after that commissioning process, the obligation for the customer starts in terms of maintaining the operation of that system in the proper way. And this is very important because our buildings are dynamic and our systems, they tend to stay connected and protecting a building for 10, 15, 20, sometimes more years. So the compliance with the service becomes a key part, especially to follow the dynamics and the evolution of the different parts of the building, making specific attention to the programming of the detectors. As we learned before, multi-criteria detectors have a myriad of different programming possibilities, and that needs to make sense with the use of the room. In Europe, there's been significant effort trying to produce norms, standards that look into the testing and the maintenance of the system. There is today 54, in line with the EN 54, but not fully. EN is only a technical specification. That means it is used as a guideline. But it gathers most of the best practices and it serves as a guideline for the local code of practice, to which I will refer in the next slide. Also, Thomas already mentioned the EN 16763 is a norm, not a harmonized norm, but it is a very good reference to qualify the quality and skills of a company that is performing the maintenance and technical services of a system. So what I can show you here is the local code of practice in a lot of European countries, not all of them, but many of them. I just gathered several just to show as an example. They have partly used TS 54-14 as a guideline, but mainly the information that we have is this local code of practice. They have been using local big fire events, very often catastrophic events, to shape and form the local code of practices. The second very important source has been the comparison. So many of the local codes, they follow best practice example from other European countries. So we can talk about three sources of information or guideline for the local code of practice, TS 54-14, and the events that have impacted the countries and the comparison with neighbors. I'm going to today refer especially to the digital tools that help customers remain compliant and do all the services and all of the maintenance through all of the life cycle of the installed systems. And we have supervision tools in the form of mobile app or dashboard. We have compliance tools that are usually in the form of delivered reports or online reports that can be called for inspection. There is also the efficient operation, which is basically the interaction of different parties, can be facility management and the technical department of a service provider, that today is highly improved by digital tools. So we've seen in the last years a growth in the efficiency of the activities. And then last, we will see that there are very powerful tools showing analytics that help shape and keep the system up to date and with the highest level of reliability. So when we talk about supervision, we are usually referring to online real-time tools or near real-time tools that are present in the form of an app, a mobile app that can be visualized from phones or tablets, or it can be dashboards. And the information presented in one and the other is similar, but not the same. So dashboards offer the possibility to display maps for multi-building operations. Certain facility management organizations, they have several buildings across countries or across different geographies. So we see that apps and dashboard tend to evolve, complementing each other, and today a very useful tool, especially in order to anticipate and react fast to events coming from the fire system. Moving forward, we have today tools that support the compliance. This is a very crucial topic for owners, not only towards fire authorities, but also towards insurance companies and towards the company itself. Many facility managers, they need to show for different buildings where they are in terms of the availability of the systems. So this type of reports, for example, performance reports, they can show not only the usual events like alarm and pre-alarms, but also the isolations, the time to resolve faults, and also the availability KPIs. Another part of the compliance is the logbooks. In most of the countries in Europe, a logbook that collects all of the events coming from the panel, so events that are produced by the electronic detection of certain alarming events or fault events, need to be registered in today, in most of the cases, a paper logbook that needs to be filled in by technicians and facility manager. So the digital tools are offering today electronic logbooks that would capture automatically all of the events coming from a panel. And that solves a lot of different shortfalls of the paper logbook, in the sense every event is registered. Every event, it is readable, so there is no complication with difficult handwritings. It is always there. Very often logbooks might go lost. The events are timestamped, tamper-proof, so it becomes a proving element toward the authorities. So the fire, the insurance authorities, that there is a strong proof of concept that the system was doing what it was supposed to be doing, and the maintenance was done appropriately. Moving forward from compliance, we go into the efficient operation, and this is a huge help for facility management, in the sense that troubleshooting is no longer about understanding what is this message in the panel and how do I react to this type of fault. The constant communication from the panel with digital support centers can provide a troubleshooting that resolves the issues in a fraction of the use time. Not only that, but there are also several events that can trigger automatic tickets that help react technical services and facility management, and also the preparation of the interventions that can now be done exploring the situation of the site and maybe having spare parts on the track and solving topics in one single intervention. So the operation has become very efficient based on digital tools today. And last, systems can deliver very powerful data for analysis. So as we mentioned before, buildings are dynamic. We also mentioned multi-criteria detectors can have very different programming parameters. How is the evolution of the building being reprogrammed or followed by the programming of the individual detectors? That is something that today can be supported by electronic tools. So understanding in a big campus which are the detectors that have observed a certain danger level, a certain detection situation which is not supposed to be the one they were programmed for, is very useful information to avoid the false alarms. Still today, according to the study performed by Euralarm, most of the automatically generated fire alarms are false alarms. So in the future of our industry, one of the big topics we have to solve is the false alarms and making our facilities more resilient and following exactly the evolution of our buildings. The other topic that is a headache for facility management is the accumulation of contamination in the detectors. And this is something that today can be available in reports. For small systems, probably not so important, but when we have a big campus with many different type of risk and some clean and some dirty areas, the evolution of the, I would say, cleanliness of the detectors is valuable information because it avoids business interruption and avoid needing to react to situations that could have been planned. So today, there are reports from many different vendors in the industry that show us exactly what is the situation of the detectors and by when they would reach the point where they are no longer reliable. Okay, with that, I would like to give over to Oliver.
So, first of all, can you see the slide?
Yes.
So, testing and maintenance, can you see the slide?
Yes, we can, Oliver.
Okay. So, first of all, hello everyone. So multi-sensor detectors can help to reduce false alarms. And today you've heard a lot how they work, what they can do, and what to consider. I think I would like to repeat what Thomas said. Euralarm have published a white paper on this topic. It was published a little bit earlier this year, and it's highly recommended for you to read it. So please, after this webinar, have a look at it. For my side now, I want to build on some of the points that were discussed by my previous presenters. And for example, Mikhail showed you a nice overview of the various codes of practice that apply in the various countries. And you know, in many ways, it's in the name of all of them. Because what I mean by that is they not only talk about design, installation, or commissioning, but they also talk about maintenance. And after all, this fantastic technology, these multi-sensor detectors, they need to work throughout their entire life when they're installed. Like I said, the installed detectors, they need to work for many years. I think both Thomas and Miguel said it very nicely about the building dynamics. Building spaces change over time. For example, room uses change over time. and there's always something to look out for. I also really liked the various photos Thomas showed you about the different environments, and I mean, I guess in many ways the picture says more than 1,000 words, and the reality is not all environments are clean office spaces. A lot of them are a little bit dirtier environments, or used for not office space but for manufacturing, etc. And this might, of course, inform your maintenance plans. After all, like I said, these detectors are in place for many years and they need to work as intended. The overview, I really like the overview Miguel had, and please also, my point is always refer to your local codes and guidance. I mean, there's quite a few people from many different countries on this webinar today. But when it comes to sort of a typical testing and functional testing of detectors, like a multi-sensor detector, they should be functionally tested at least once a year. But like I said, don't forget the environment. Sometimes it could make sense to have more frequent maintenance and test regimes. And like all the previous speakers today said as well, nowadays there is just a little bit more scrutiny and hence more demand for better compliance and records, including digital records relating to maintenance. You've heard a lot about digital records and records with fire detection alarm systems, but also some of the latest functional test solutions also have the ability to capture digital records for compliance and better records and reporting. So, I think when people talk about functional testing or do maintenance, they look at functional testing and probably look at the photos on the right-hand side. But functional testing remains a common practice around the world. But remember, maintenance is not just the functional test; it's also the visual inspection. So they go really hand in hand. And let's start with the visual inspection. Again, I really liked Thomas's real-life situation photos. It was almost like a sort of hall of shame, but we all have seen them, and the fact is, they're the reality in the field. I mean, we see a lot of detectors being obstructed or maybe too close to the wall. Actually, the hotel I'm staying in today, the detector here is far too close to the wall. Too much airflow near detector, or even in the worst case, sometimes covered up detectors. All these things still happen. And I guess this makes still a case then for a competent person to conduct regular maintenance intervals on site to ensure that these issues are picked up and dealt with. When it comes to the functional testing of detectors, like was mentioned before, please refer to your local codes of practice. There's of course, some guidance in 54-14, but specific wordings vary across. But a functional test is worded, for example, in BS 5839. Part 1 here in the UK remains a common practice around the world, and by that I mean a method that confirms that products of combustions like smoke or heat in the vicinity of a detector can reach the sensors in the chamber, and that a fire signal can be produced as appropriate. And always the guidance is to follow manufacturer's instructions as well. So let's talk a little bit about the specifics and about the various sensors. I mean, you do have, I can, and Thomas showed you the 3 core sensors in there. Common sense a little bit, always, when you use it, always use test equipment that is fit for purpose and follow guidance. When it comes to the heat sensors and heat testing, use suitable heat sources that don't damage the detector and sensing elements. The heat source should never have the potential to ignite a fire, and live flames should not be used. You will be surprised how many cases I still come across where this is being done. So for most of us, it is common sense, but it does still happen. Similarly, when it comes to smoke sensor testing, you've quite a few options here. I mean, you have got aerosols that are still around and used, or you've got test equipment using smoke cartridges. Both of them do the same thing, but both mimic the particles of the different types of fire, as explained earlier by Eike. Probably I would say, in general, smoke cartridges offer a more controlled way of smoke stimulus generation. There's just a little bit more automation. But whatever you choose, make sure that the materials used in those do not cause damage to the detector. Make sure that they do not include harmful substances like silicones that could lead to contamination of the detector. And this is exactly what we don't want to have with these products. And similarly, when it comes to CO testing, test gas and test cartridge should not cause damage to the detector or affect subsequent performance. Now, there are also some specific considerations for multi-sensors. Here, I mean, you rely on multiple sensors possibly, and here is every sensor that you rely on needs to be tested, and of course you can test them individually. However, where a detection system allows you to simultaneous stimuli and individual sensor response to be verified either individually or collectively, then you can use, for example, a combined testing solution as well. And that could help you to streamline your process a little bit. Obviously, it's just a quicker way of testing, and productivity is important. And then the final one point I want to raise, and I think it was also a little bit more spelled out in the latest BS 5039 Part 1 Code of Practice here in the UK, is actually about the time clock. When you have a multi-sensor detector, you might have a detector configured differently in different modes with different sensors during the day than during the night. And if you do so, it is really important that the time clock is correct time and set to the correct time. Because you want the detector to function as intended during your day or night. Stating a little bit the obvious, but it is really important for time-related filtering measures. So, thank you very much for listening. And now I hand you over back to Thomas, who's going to wrap it up with a final summary.
Yes, so I would like to draw the conclusion of the different parts what you have heard from this webinar. We have seen in the beginning that the multi-sensor fire detectors, they integrate different sensing elements like optical, thermal, and chemical sensors, and this can be used to improve the fire detection and the accuracy of the fire detection. Therefore, the detectors are capable to reduce the false alarms because they analyze the multiple criteria and also take into consideration the environmental factors. We have also seen that it is important to take an eye and a close eye to the installation, to the proper installation, to the configuration, and also the maintenance. They are crucial then for a good and optimal performance of the multi-criteria detectors. We have also pointed out that it's important that these use detectors are compliant with different standards in the EN 54 series and for the maintenance work for the EN 16763. And we also have learned that digital tools are and remote supervision of the multi-criteria sensors enhance the maintenance and assist the maintenance and the efficiency of the system monitoring. Therefore, it is important that the multi-sensor detectors, they are adaptable to various buildings types, and also we have seen if the building type changes, it has to be adapted by the sensors. So to draw the line and to conclude in a nutshell, we come to the conclusion that multi-criteria sensors contribute to a more effective fire protection, and they reduce the false alarm, and with reducing the false alarms, they have a positive impact to the operational reliability within the production site or within the building where the system is installed. So this concludes now the webinar. In the name of all the speakers, I would like to thank you very much for your attention, and I would like to hand over now to Paul, and we will be happy to take your questions.
Thank you for the presenters, and I think a lot of information shared in a very short time. And I would like to invite people, if they have any questions, to put them in the chat, or if you want to speak up, you can raise your hand, and you can take the floor also if you want that. I have a few questions which came in. By the way, I got 2 questions through LinkedIn. I don't know why people don't use the chat, but that's typical. Eike, I have one for you, which is, and if other ones want to come in, please feel free to do that. You explained how multi-criteria sensors bring the 3 sensors together. The question is if the decision of taking an alarm or making an alarm is taken by the sensor, or if there is also a role for the control panel, for the fire control panel.
So in principle, for the multi-criteria sensors, they make decision themselves, and then they say, well, I go into alarm or not, after they kind of have used the information from the different sensors. So in that sense, the decision is made in the detector. But to make it more complicated, principal fire alarm systems do allow that the CIE may also kind of wait for a second sensor to bring an alarm information before it decides to go into an alarm state. So in that sense, there are 2 ways to do so. Yeah, also the control panel has some role in it, but in the first place, the multi-criteria sensor is such, they already make a decision kind of as part of being a multi-criteria sensor, making use, and don't even forward alarm information if they have not verified internally.
Okay, thanks. I've one, and I invite, I don't know who wants to take this one, but multi-criteria sensors in general have a higher cost. Can you say something about the cost versus benefit of multi-criteria smoke sensors? Miguel or Thomas, feel free to.
Yeah, my first thought was, what does fire brigade cost if it is not a real alarm, and if you take this into consideration. But seriously, yeah, it is correct. Of course, it has more sensing, it has more software, it has more. It's also more testing. Also, the certification process has a higher volume. Therefore, the costs are higher. But on the long run, what we pointed out, together with the correct installation, the correct maintenance, the option that you can monitor it from the remote and you can collect data, I would say that the benefit will be much higher than what the cost is for buying the product. It is, I think, important in the very beginning, especially in the planning of the building. Of course, you have then the bill of the materials. I think it's also important to address the total cost of ownership. That means, what is the benefit during the lifetime of the sensor? And then you can also convince the building the person who owns the building that it has advantages and benefits to use multi-criteria sensors.
Yeah, I would just like to add that these sensors and the fire systems today, they tend to accompany the life of the building. So it's not unusual that they are 15 to 25 years installing the building. So the total cost of ownership is for sure gonna pay off the surprise of multi-criteria detectors.
That's in line with the question which was asked by the same person. Are there any local building codes in countries which mandate multi-criteria sensors? And that's asked in relation if it's proven that it creates less. I don't like the word false alarms, but unnecessary alarms or nuisance alarms. Is there any country in Europe where it's mandated?
Not that I know.
No, not that I know.
Okay. There's maybe some work to do then. That's also possible. Well done. Oliver, are there any advancements in towards remote testing and self-testing if you talk about multi-criteria sensors? Because you can do everything remotely, but how is the impact then on the remote testing or the self-testing from sensors, which is then reported remotely?
So Paul, was that directed at me, please, or?
I think you're the test expert.
Okay. So I think that's it's a new technology. And I think my guidance would be sort of please look at your local code of practice if it's permissible or not, or what methodology is permissible or not, and that does vary. Also, if you have those, follow the guidance, the instructions from the manufacturers. I think that comes down to choices people have. And of course, I have to be upfront here. I'm not an expert in self-testing technology. I think some of the manufacturers would be that. But I would say is that self-testing has, of course, raised the visibility and importance of maintenance and testing, and I think that's a good thing for the industry as a whole.
Okay. Michael or Thomas, anything to add to this?
Yes, I just want to stress what Oliver just said. It is important to start by the local code of practice and what it mandates, what it requires. The second comment is the self-testing technologies are a support for the maintenance. So there is one key part of the maintenance, which is the inspection. And I think the American codes, they refer very often to ITM, inspection, testing, and maintenance. And I think all the three parts are key for making sure that the system remains in well or in proper operation status and compliant.
I mean, I think if I could, I think Miguel put it very, very well. And I think, this webinar is, of course, about sort of how technology can help. But, like the inspection, visual inspection is still an important part. So, and I think, a lot of the photos, for example, we showed, it was about things that need to be picked up. And I think that sort of the visual inspection goes with the testing hand in hand, like I said in my few slides.
Okay, thanks.
And I think I add, I think it's a assistance and for the service provider to also to make sure that the maintenance can be done in a proper way, and the self-testing elements, and it will advance. I'm sure about that, and we also know it's not so easy to find the people to go into the building to do the job, or there are areas where it's not possible to go into the building due to processes, product processes, and so on. And there I see that it will be play an important role to have this self-sensing or self-testing elements also for the multi-criteria detector.
Yeah, one comment is, and I think Oliver mentioned that already. One of the benefits of self-testing is that I can decide for some critical operations to test on a regular basis. So the ITM with an expert technician on site can comply the regulations and have one or several visits per year, but I can choose to have a self-testing that is running once a week, once a month. I think that is an additional benefit, helping increase the resilience of our buildings.
Thanks. I see no other questions in the chat and also not in the Q&A. So I see a hand raised, and I see a second hand raised. So I see Peter, Peter Massenberg-Mundy. Please, Peter, go ahead.
Hi, yes, just very quickly, on the first question, whether the detector or the panel makes the decision, it really is up to the manufacturer as to whether they transmit analog values back to the CIE or do anything. The decision does not have to be made into the detector by any means, but as part of the standards. So I think that just needs to be clarified. It doesn't matter where the decision is made, it's the system that makes the decision ultimately. So that was one question, and the other thing I was just going to touch on is on the self-testing, and that's just to emphasize that one of the advantages of a self-test type detector is the consistency of the self-test that happens at every time. So one of the things is to try and use the same equipment every time that you're using a test, and then you get some trace as to what is really happening with your detector over time. And that's one of the benefits of having a self-test, is it's that consistency is actually guaranteed. That's just the one thing I wanted to add to the discussion. Thank you.
Thank you very much, Peter, for the addition. There's one other hand raised by Liebert Wolf. So Liebert, please go ahead.
Yes, it's Wolf Liebert. I just want to add some comment to this multi-sensor detector and the testing of the detector. One of the main features of this multi-sensor detector is that they are not sensible to one phenomena at all. Needs a combination of several phenomena. That means that a detector is more intelligent, and it is able to distinguish the fire from a non-fire situation. So when it comes to the testing and they said, okay, I just inject some test gas, which is not a fire, then the detector itself will not react, because it's notice, oh, it's not a fire, it's just a test gas. So I will not signal any fire. So, and this is a basic feature of the multi-sensor detector. So the testing itself, it gets more complicated. So that means when you use this normal testing features on testing equipment, this detector will not react at all, because it's not a fire. It's just I don't know, it's just a heat or just a smoke, test gas or something else. So currently the detectors are set to a testing mode to kind of simulate something that it says, oh, I'm now not a multi-sensor detector. Now I'm just reacting to test gas, and then I will signal something. So the functional test is kind of not really functional test. It just try to simulate something. And this situation gets more complicated when the detectors are getting more and more intelligent. So they just ignore this testing equipment. And in this sense, I think these self-testing features are getting more and more important, because then the equipment will test itself. So are the detector are working correctly? Are the sensor are working correctly? So I just want to mention that the self-testing features are getting more important for these more intelligent detectors, like these multi-sensor detectors.
Mm-hmm.
Okay, that's all.
Thank you. Oliver? Oh, you're on mute, Oliver.
The detectors are becoming more complex, and of course, but then of course I would also say the test equipment for the functional test also gets more advanced. I think with multi-sense is an interesting one, of course, because you can set it just to smoke, but it also could be, relying on multiple sensors to pick up and trigger an alarm. And of course, some of these tools are where you can actually have not just smoke being generated, but smoke, CO, heat, and all combinations to make sure that if a detector relies on 2 or more sensors to being activated, that it can do that. But I think is with this is I think a reason why test equipment does get more complex as well.
Yeah. Before we close off, I have a very interesting question for you, which the role of AI going forward for multi-criteria sensors.
Well, I think, it's definitely a way to train sensors, right? And so that may play a role, but at the moment, we have to qualify them against the existing standards as they are. So before this is not kind of made a possibility, and also kind of somehow proven that it enhances actually the detection quality, I think this will not be established, but I guess that's definitely a direction that things might move in future.
Okay. Thank you. Before we close off, Patrick, I see you raised your hand, so I would like to give you the opportunity to speak.
Yes, thank you, Paul. Hello. I don't know, is there a problem with the Q&A? Because I put it a question and my colleague Chris Baert also. Are you not seeing them? Well,
No.
Put my question on this way then.
I see. Sorry, I see them just popping up. but please give your question verbal. No problem.
Yeah, well, just a statement. Is it correct if we can say that due to the technology of the multi-criteria detectors, they will react slower on a fire for the detection than, for instance, a pure optical sensor by the speed of reaction?
I can comment if you want. In my experience, no. In my experience, is a question of choosing the right parameter sets, and that is not always easy because the rooms tend to behave sometimes or very often in ways which are not expected. But if you compare the different type of multi-criteria detectors against the fastest optical or even ionization detectors, if they have the right programming, they can react as fast as.
Thank you.
And the other question comes from Chris Baert. In Belgium, detectors are expected to be replaced every 5 to 8 years with drift compensation. What is your view on this? Is this still necessary with intelligent detectors? Go ahead, Thomas.
Yeah, I can make a start, and if you would like to add it. I think that this what I also had in the presentation about the maintenance and the importance to have a look at the conditions of the detector, and then if necessary to remove it. This will still be a way, to make sure that we don't have false alarms and to have the detector working in the proper way. I'm always saying it's a safety device. It is to protect life. It's to protect properties and buildings, but in the main purpose to protect life. And therefore the electronic has a degeneration, and therefore it is important also at a certain point to exchange and to exchange and replace the detector. On the other hand, I think it is the technology we will have with self-testing, with remote access. We will be able to define the correct time when the replacement is necessary better, because we have more data, and then we can define this this point where it is necessary to be replaced in a better way.
Okay. Thanks for that explanation. Good. I think we have come to the end of the webinar. I want to thank the presenters. I want to thank also all the people who were online. If you're interested in the work from Euralarm, please visit our website at the euralarm.org website, where you can find all the information. You can also follow us on LinkedIn. And if you're interested in one of our meetings, we have every quarter an online meeting where you can be invited as a guest, or if you want to join us in person, you're more than welcome to join us in Athens in November for the Euralarm section meetings, and there's also a small industry event. So thank you all very much for joining, and I hope to see you in one of the next webinars from Euralarm. Thanks.